Rising 1,600 feet, this tower will redefine Park Avenue. Citadel will anchor the massive state.
New York has buildings that move every day. Wind pushes them, people occupy them, elevators accelerate through them, and the entire structure responds by tiny amounts that are almost impossible to see from the street. Now Midtown is preparing for something much larger, a planned 1,100-foot Supertall at 350 Park Avenue, a $6 billion project whose very design depends on controlling movement at a scale most buildings never experience. Structural engineers know exactly how tall towers behave in wind. What remains unknown is how every detail will perform once this particular building exists. This is 350 Park Avenue, and the problem isn't fixed. The project exists because Park Avenue became a contest for premium office space. Vornado Realty Trust and the Rudin family assembled the site with Citadel founder Ken Griffin, whose companies will anchor the new tower. Foster Plus Partners designed it, with Adamson Associates as architect of record. The brief was unusually direct. Create a new Midtown headquarters scale office tower, large enough for major financial firms, while opening part of the site to the public. The site wasn't created overnight. In January 2023, Vornado and Rudin completed agreements involving Citadel and Griffin, bringing the properties together for redevelopment. New York City Council approved the project unanimously in September 2025, and then the engineers started doing the math. The approved design rises about 1,600 feet over 62 stories, with roughly 1.8 million square feet of commercial space. Citadel and Citadel Securities are planned as anchor tenants, with the companies expected to occupy hundreds of thousands of square feet. There will be a 12,500 square foot public concourse along Park Avenue, terraces, retail and restaurants, and a fully electric building designed for LEED Platinum and WELL Platinum targets. Dotted is a serious piece of architecture. The structure is being developed with Thornton Tomasetti as structural engineer, Severud as peer reviewer, Langen handling geotechnical and support of excavation engineering, and Rubidi performing wind tunnel testing. The current plan anticipates completion in 2032. But that is not the remarkable part. The remarkable part is how much engineering disappears once a Supertall looks finished. Let's talk about what happens structurally when you make a building this tall. In a normal building, gravity dominates the conversation. Floors push downward, columns carry the load, and the foundation transfers that force into the ground. The moment you stretch a tower towards 1,600 feet, wind becomes a second structural system. The building doesn't simply stand there. It bends and sways. That movement is called lateral drift. Sideways displacement caused mainly by wind and other horizontal forces. All tall buildings experience it. The engineering challenge is keeping that movement within limits, so the structure, facade, elevators, and people can continue functioning normally. Think about what that means for a building with 62 floors. The response begins long before anyone occupies the tower. Wind tunnel testing is part of the design process, and the project team includes Rudai specifically for that work. The structure also has a dedicated peer review engineer, Severud, checking the structural design independently. The published project material lists 36 passenger elevator cars, 3 freight cars, and 2 lift cars, alongside 4 below-grade levels. The tower is planned at roughly 1.8 million rentable square feet, with typical floor-to-floor dimensions around 16 feet 2 inches. The alternative isn't simply to make everything heavier. More steel and concrete add weight, cost, and foundation demand. The actual design has to balance stiffness, strength, usable floor area, construction efficiency, and wind response. And this part barely gets mentioned anywhere. A tower can be structurally safe while still moving enough to affect ordinary systems. Elevators have to remain precisely aligned with their shafts. curtain wall joints must accommodate movement. Doors need to operate. Plumbing connections need flexibility. Mechanical systems need tolerances. Here's the thing about 350 Park Avenue that every Supertall engineer knows: movement isn't automatically damage. The public renderings show a stepped, tapered form with curved glass and column-free corners. That geometry isn't just decoration. The form changes how wind meets the building, while the structural system has to carry gravity and lateral loads through a very tall, highly efficient office tower. That part doesn't make it into the architecture magazines. And there is another complication. This building isn't finished yet. Demolition is underway, steel fabrication has begun, and the current target is completion in 2032. So claims that the tower is already moving in a dangerous sense would be wrong. There is no occupied 1,100-foot tower to monitor yet. That distinction matters. The incident so far is not a structural failure. It is the movement of the project itself through one of New York's most complicated construction environments. The City Council vote came in September 2025. Technical review followed. Demolition began in 2026. Steel fabrication was reported in August 2026. Within months, an existing block is being dismantled. Within years, it is expected to become one of New York's tallest office towers. Nobody was hurt in some dramatic structural event. There wasn't one. Compare that with towers that have actually experienced serious movement problems, such as Boston's John Hancock Tower, where facade panels failed during construction in the 1970s. Or London's Millennium Bridge, whose unexpected lateral movement forced a major engineering response after opening in 2000. Here is the fundamental difference between 350 Park Avenue and every other Supertall we've covered. This one is still in the phase where engineers can change the building before the building changes them. The real time bomb is time itself. Steel can fatigue under repeated cycles. Concrete can creep, meaning it slowly deforms under sustained load. Connections can age. Facades experience temperature changes thousands of times. Mechanical systems wear out long before the structure itself reaches the end of its design life. There is no historical data for what a 1,500-foot 350 Park Avenue looks like at 50 years. Because no 350 Park Avenue is 50 years old. This is the first. It is the only one. By 2076, engineers inspecting the building will have something today's designers don't have: decades of actual measurements. They will know how the facade moved, how the structure responded to storms, how elevators aged, and whether the assumptions made in 2026 matched reality. Right now, those engineers don't exist as inspectors of this building. They're future readers of its data. And today, people are already working around the site. Citadel is preparing for the new headquarters, while construction crews are replacing an existing block with a building designed for thousands of workers. The completed tower is planned to hold roughly 6,000 employees. Someone will eventually stand inside an elevator, coffee in hand, watching Midtown slide past the glass. They won't feel the steel calculations. None of them are thinking about how many millimeters the tower moved in the last windstorm. A worker is building the future skyline right now, piece by piece, while the final building exists only in drawings, calculations, and steel being fabricated. The question isn't whether 350 Park Avenue will move. It will. The question is how precisely the engineers can control that movement for decades. Drop it below. Would you work inside a 1,100-foot tower like 350 Park Avenue? See you in the next one. Thanks for watching. Please subscribe to my channel.